Thank you for, first of all, I would like to thank Balwinder sir for giving me the opportunity to deliver in a corresponding workshop. And this is TinkerCAD Simulator. Recently, we are doing so many projects, IoT projects on this. So with this, I want to plan this total morning sessions into 3 phases. The first phase completely deal with what is TinkerCAD and how the tool has to be installed, and anyone can how to use that particular TinkerCAD. And second phase, I want to introduce what are the essential circuits are there. Essential components are there in that particular TinkerCAD. And third phase completely will do with lab sessions. Okay, so I'll share my screen. Is my screen visible, sir?
Yes, ma'am. Yes, ma'am. It's visible.
Yeah. Right. So this is TinkerCAD Simulator, and this is open source software which can be useful for the IoT projects with virtual Arduino. So the meaning of this virtual Arduino is there is no physical Arduino and there are no physical hardware components. Even then we can do some type of prototype and then we can design some IoT project. So that is the use of this TinkerCAD Simulator. In the first phase, as I told, I have divided the total topics into 3 phases, and in the first phase, I want to tell you about what is TinkerCAD and what is the importance of this TinkerCAD. Okay, so the first outline of this is what are the benefits of this TinkerCAD and what are else open source softwares are there, and what are the essential components, and what are the existing sensors are there in the TinkerCAD, and how the IDE will be developed with the help of this TinkerCAD simulator. So before going to this, as I told, so it's a virtual Arduino. So virtual Arduino means really if I don't have the Arduino like this, so this is an Arduino. Okay? So if I don't have the Arduino like this, and if I don't have the hardware like any sensor or breadboard or whatever it is, so then how to do the prototyping? So how to do, or this is very useful in lockdown period. So many of our students did their mini projects, major projects by using this TinkerCAD. So if there is no physical Arduino and no physical hardware components, and still if you don't have any programming language like C, C++ or whatever it is, then still it is possible to construct or to prototype any IoT project. So that is the benefit of this virtual Arduino. So, and like the other softwares, here there is no installation required, and because this is an open source software and with a free of cost. So these are the benefits of this virtual Arduino. And without the programming knowledge, how this is going to build that particular circuit is by means of blocks. So there are existing blocks already defined in that particular tool. So we have to drag and drop all the blocks and we have to customize that particular design. Then we have to simulate it. That is the procedure with the help of this TinkerCAD. Okay, so there are so many open source tools, virtual programming tools. In that, the first one is Xbody.io. So this is one type of open source tool, which is also a block programming. And the second one is Visuino. Third one is TinkerCAD. And fourth one is Fridging. And fifth one is NodeRED. So these all 5 are open source virtual programming tools used to construct or used to prototype any IoT based project. So we can do all these Arduino based projects, but by assembling whatever the blocks. So the name of this particular software, we'll call it as block programming. Okay. So that coming to the first one, xbody.io. So if you want to download this, so this is a site, https xbody.io /downloads. So you can install this on the desktop version. So, and this is an IDE example, and here each and every circuit is treated as a node. So I've given this screenshot here. Each and every circuit, like a LED, it is also considered like a node here. And whatever the circuits available in the existing library, so we can drag those particular elements onto the workspace, and we can customize this by connecting the node to node, and then we can simulate here. Okay, so this is here everything is represented in terms of a node, and we'll also call this as a block. So in case of this motors, relays, or whatever this sensors, everything can be in the form of a node. Okay, so this is Xbody, and the next one is Visuino. So this is mainly, this is innovative tool by some Bangalore software company. So call it as Mito software. So it supports all the Arduino boards, Raspberry Pi, Femto IO. These are the recent microcontrollers, and as well as ESP8266, ESP32, FreeSock, System on Chip 2, and there are so many other Arduino clones also available. So this mainly this is useful for developing robotic projects, robotic based projects. And this is a link to download this. This is also a desktop version. You can download and then you can practice it. So the third one is the TinkerCAD. So mainly this TinkerCAD is useful in three ways. The first one will call it as a 3D design, and the second one will call it as a electronics, and the third useful use of this TinkerCAD is code blocks. 3D design is, so once if the college is having any 3D printer, and if you people are able to design any or create any particular circuit, like any cube or whatever it is, some small project to a big project, and whatever that particular 3D file can be downloaded, and if I copy it on a pen drive, and if I place it on a load it into a 3D printer, then that particular regarding that design can be prototyped. Okay, so that is the use of this 3D design. And also we can do so many sort of the electronic projects by programming. So here the programming in the sense by block programming, or by after programming we have to simulate it after assembling the, or after customizing these all the elements in that electronics. So then the code blocks is here entirely the design is based on the code. Okay, the next one is Fritzing. This is also open source tool. So mainly this is useful for documentation and also the PCB manufacturing. So the same tool, we can do the Arduino project here in one window. So that is, this is, we'll call it as a main window. And the next one here is, this is a schematic window. So the exact, whatever the design we did in the workspace, the same schematic will be appear in the schematic window. And there is another window here. So that is, we'll call it as a PCB window. So whatever the design we did in this first case, the corresponding PCB layout design will be appeared in this third window. So this Fritzing, it consists of three, and there is one more window, we'll call it as a documentation. So how we connect it? So suppose if I take any Arduino, one LED is connected, I want to control the LED intensity. So the same thing I have diagrammatically drawn here, but whatever the theory behind it, everything is documented by this particular Fritzing software. So almost all the students are using this Fritzing for their documentation purpose. So in order to keep their schematic diagrams, or even to keep the block diagram of that particular design, it is easy for them to copy. And also the documentation is readily available with this Fritzing software. The next one is NodeRED. So NodeRED is nothing but it is mainly based upon the APIs and it is completely online service. We require the internet, though the previous four we don't require any internet, but this is requires the internet. With the help of the cloud services, we can connect each and everyone together, and whatever the nodes here present here, each and every circuit is also known as a node here. So the nodes can be connected here, and by means of the resultant file, we'll call it as a node.js. Okay, so the main advantage of this here is, so to construct any circuit, and if I want to transmit that particular circuit data over cloud to the another place, so then it is useful in case of this NodeRED. Okay, so it is a cloud based one. So but today, out of these five, I want to concentrate on this TinkerCAD. So TinkerCAD, as I told, this is an open source software. Okay, so parallelly we will do here. So if I want to do this TinkerCAD, I require one account in the TinkerCAD simulator. So for that, everybody please go to any Google. Everybody please go to the Google. And type TinkerCAD. And type in TinkerCAD. And click on the first one, that is www.tinkercad.com. This is a dashboard will appear once you click on the first link. So this is what we'll call it as a dashboard. So the use of this TinkerCAD is, so here they will give, there are three uses. One is to do the 3D design. The other one is will use the electronics purpose. The other one is will use the code blocks. Okay, so simply by drag and drop, by placing that on the workspace, and by adjusting, customizing, and then combining, and then simulate. So these are the three purposes. So if I want to do anything here, what I require is, first I have to sign in. So anybody can start with sign in, and it will ask us educators, students, and student account or personal account. So everybody can log into this TinkerCAD with their personal Gmail accounts. If you have the Gmail account, you can click on this personal Gmail account. Click on the personal Gmail account. Then click on sign in with Google. Click on sign in with Google and choose your Gmail account. Choose your Gmail account. It will open your login in a TinkerCAD. It will open your login in a TinkerCAD. Everybody done up to this? If I want to open this, first I have to go to Google and type TinkerCAD and click on the first one. It will enter into a dashboard. From there, I have to sign in with my personal account, personal Gmail account. Then this will appear. Everybody completed? If you completed, please text me here. Everybody sign in? Right. So once the sign in is done, so we'll move on to the next one. Here, as I told you, there are the three different uses of this TinkerCAD. One is 3D design. Like this, we can do the so many designs. Like I've constructed one tray here, and then one blocks like a Rubik cube or whatever it is, and then a hollow disk. So once I have done this, design this particular file, whatever the resultant file, I have to download it. So that file I have to save it on a any pen drive, then I have to put it into the 3D printer. So then that particular design, it will take around 1.5 hours or 2 hours to print that. So it will print that particular 3D design. So this is the first use of this 3D. The next one is, the next use of this TinkerCAD is electronic circuits. So we can do any sort of the circuits, like whatever we are seeing, like all laboratory experiments, anything can be done with the help of this electronic circuits. And then there is a code blocks. So here the code blocks is completely we can do by means of a programming. Okay, so here I'll go to the circuits and click on create new circuit. Go to the circuits on leftmost panel and click on this create new circuit. So this is a workspace that will appear. So this screen will call it as a workspace. And leftmost, this TinkerCAD, it is nothing but it is the leftmost notation will be known as a logo of the TinkerCAD. And beside that, there is some random name. If you want to change, you can click on that particular one and you can change it as something like experiment. Okay. So then if you click on any other side, so it will be given the name for that particular workspace as experiment number 12. Okay. So, and here there is the towards right side, there is a panel which consists of the basic components. And if I see what are all the components exist in the TinkerCAD, like some general components like a resistor, capacitor, and what is the inductor, Zener diode, and even PN diode. So then there are some input terminals, like a push button is an input device, like potentiometer is also input device. There is a slide switch on and off. This is also input device. Something we are inputting onto the device, we'll call it as a inputs. And there are some outputs here. So that outputs are something is output from that particular device. So that is like LED and the tricolor LEDs, like light bulb or whatever it is. So these are the outputs. And this TinkerCAD supports some sensors. So the which sensors we'll call it as, I'll show you. So there are only some limited number of sensors are available. So one is, we'll call it as a photoresistor. The next one we'll call it as a ultrasonic sensor. This is a ultrasonic sensor, and this is PIR sensor, and this is LM35 and 36 temperature sensor, and this is a gas sensor, and this is tilt sensor. So these are the available sensors in the TinkerCAD. So we'll call this screen as a workspace. Leftmost, this TinkerCAD is known as a logo, and beside that there will be some random name initially. If I click on that, and it is allowed, it allows us to change the name of that particular workspace. And towards right side, there is a list of all components exist in the TinkerCAD. So there are some number of sensors, and there is some number of input devices, and there are some number of output devices. And similarly, whatever the basic components required, like a resistor, capacitor, and whatever this, everything is allowed in this particular component list. And if you see here on the left topmost, it is a rotate button, and then there is a delete button, redo, undo. And this is, we'll call it as a, if I want to write any comment on that particular equipment, I can drag this and write it as a comment. And this I symbol, it denotes that what is the particular explanation of that particular component. If I want to view, I have to click on this. If I don't want to see, if the nobody want to, it's my reference purpose, if I want to note it, then I have to click on it, undo, so that it will not be visible to the outside persons. And this is a set of colors that the particular each wire can be colored. So suppose if there is a ground connection, I can change the wire color as a black. And if there is any supply connection, I can change that wire color as a red, and we can change so many colors like this here. And this is a wire type, whether it is a normal wire or it is a hook type or whatever it is, alligator or automatic. So these are the components here. And towards this right side, so there is a code here. As I told you, the particular TinkerCAD supports block programming. So these are all, we'll call it as a blocks. So simply, if I want to do anything, what I have to do, I have to drag that particular component onto the workspace, and then I have to connect it. Okay, so this is what we have to do. And once the customization or once the design is ready here on the workspace, I have to do the start simulation. And if I want to see the particular circuit view, whatever the circuit view, to copy that particular circuit view on my documentation purpose, I can click on this circuit view. And if I want to do the see the schematic, so how the each component pin by pin, how it is connected, so then I click on this particular schematic view and copy that particular schematic onto my documentation. Okay, and this is whatever the components I have used. So suppose if I'm doing any documentation, so what are all the components I've used in my project? So if I click on this, so it gives you once the design is ready, it gives you whatever the components that you have used in your project. Okay, so these are the elements present in this TinkerCAD. So we'll do one small one. So coming to my PPT, so what we discussed now. So for if I want to start the TinkerCAD, I have to get into an account. So how we have to do? By means of signing with the Google. Okay, so that is the simple step. So then it will enter into the dashboard like this. And here left side panel, it consists of 3D design, circuit, code blocks. So as of now, we are dealing with the circuits. That is the second one. Click on the second one and create a new design. So once you create a new design, it will give you the particular workspace. So suppose if I want to click on the 3D design, so we will do that. We will see how it is. Suppose if I want to go back to the dashboard again, I have to click on this TinkerCAD. Place the cursor over there and click on that. So if I want to do how the workspace for a 3D design, so click on this 3D design and create new design. Create new design. And this is how the workspace for a 3D design will look like. And here also leftmost, this TinkerCAD refers the logo of that particular circuit, and this some random name which is given. If you want to change your something, name the particular workspace, you can write your own name. Okay, and here right side there are some blocks here, basic shapes. So like a cube or whatever, a cylinder or whatever a cone we have. So if I want to do any customization on this, and similarly if I want to write any text on this, so I can write this test name, whatever the text name. So if I click on that and if I change that value as a FDP, so it will be appear like this, FDP. Okay, under FDP, if I want to write, if I want to do any some design to represent the meaning of this FDP, so then I can design this. And if I download this particular, after design, customization is done. So if I download this file and if I save it into any pen drive and put it into a 3D printer, so the corresponding design will be, prototype will be ready. Okay, so this is your 3D design. Okay, so this is the 3D design. So we can do n number of 3D designs, and once the design is done, so that model we have to copy onto a pen drive. So this is a workspace for a 3D design, and this is a workspace for a circuit the second one, circuit. And here if you want, so as I told you, so this is a if I want to do any title of the project, I can change over here. So initially they will give some random name. So after that, by clicking on that, we can do we can change the title of that particular project. So else everything I explained here. So next, so what is the sensor? So can anyone know what is meant by a sensor? Sensor is nothing but, as the name implies, it senses something, right? So by it reads something, right? So whatever, by any electrical physical stimulus on that, it tries to read that particular signal and it produces the output. So that is what the sensor is. And sometimes theoretically we'll also call the sensors as a transducers, but practically both are different. So the sensors are nothing but only after a stimuli it is going to sense something, okay? But the transducer is nothing but it tries to convert one form of energy into the another form of energy. So this is a slight difference, but theoretically most of the textbooks says that sensors and transducers are same. So but practically sensor use it to sense that particular electrical signal once the stimuli is given, but the transducer tries to convert one form of an energy into mechanical energy into electrical energy or whatever it is. Okay, so what are the basic sensors available in TinkerCAD? So there, just now I showed you. So there is a gas sensor, flame sensor, tilt sensor, temperature sensor, ultrasonic sensor, PIR sensor, piezoelectric crystal, LDR, RTD, thermocouple. So these are the basic sensors. So you know the what is the principle behind in thermocouple, right? So thermocouple is nothing but, as the name implies, thermo means temperature, is tries to convert it into voltage. So and similarly RTD, resistance temperature, so means that the temperature converted into the resistance. As temperature vary, the resistance of the device is also going to vary. So LDR, what is LDR? Light dependent resistor. So this particular LDR sensor, it depends upon the light intensity. So as the intensity vary, the resistance of that particular device is also changes. Okay, so that is a principle. And similarly, the piezoelectric crystal. So here it depends upon whatever is the pressure in that particular crystal, and that particular pressure is converted into voltage upon sensing that particular stimuli. Okay, so then PIR sensor, PIR stands for passive infrared. So it detects any warm body is there near to that sensor. So like any human being is walking surrounding by that particular sensor, or any animal living being is walking or there in front of that particular sensor. It tries to detect any warm body. So the gas sensor is nothing but if there is any, what is the concentration of the gas in the atmosphere if I want to measure. So that is a gas sensor. Okay. So then ultrasonic sensor, usually ultrasonic sensor is used to measure the distance, and this is also useful for making in terms of a blind man stick. Recently we did one 3D printing project. So we printed one long stick of 1 meter for a blind man persons, and we kept 3-4 ultrasonic sensors. One is at the bottom level, and the other is at the middle level, and one is at the handle level. So and also we kept one level sensor, so to know what is the, whether there is any up step or down step, so while the person is walking stairs. So with that we designed one prototype to for the for helping the blind man step, blind man persons, blind mans. Okay, so this is under the testing and all is over. So only we are going for a blind man school for testing that particular whatever we designed our prototype. Okay, so that is the main use of this ultrasonic sensor. It is tries to measure the distance to an object. Okay, and then the flame sensor, Flame sensor is used to detect the flame. So suppose even we are trying to keep one flame sensor for the blind man stick. Suppose if there is any flame near to that particular blind stick, and we have to connect on the beside of this flame sensor with a buzzer. So the buzzer will ring up. Okay, so that the person will be secure and he will move to the other side of that place. So then similarly temperature sensor, so it is used to measure the temperature. Here there are two temperature sensors available here. One is LM35, the other one is LM36. So these are the basic sensors available in TinkerCAD. So before going into how to do this, so we need to know about what is Arduino. So we don't have the physical Arduino, so but there is a Arduino block available in the TinkerCAD. I'll show you. Arduino block available in the TinkerCAD. So if I want to see that, I have to go to circuits, create new design. There is one search button over here. I can type this as Arduino here. There is only one Arduino available. I'm dragging and dropping on the workspace. Okay, so this is how it looks like. So I'm showing you this. This is a physical Arduino which I have for my experimental purpose, and this is a virtual Arduino. Okay, so this is what we'll call it as a virtual Arduino. Okay, so what is the purpose of this Arduino? So Arduino here is nothing but it looks like this. It is an open source physical computing platform, but it is not a microcontroller. So like we know already the microcontroller is nothing but the everything microprocessor plus whatever the inbuilt memory, timers, whatever everything is available within a single chip, then we'll call it as a microcontroller. So especially this Arduino, it is only a platform which supports to connect all the elements to within that particular platform, but it is not a microcontroller, and it is founded by Massimo Bangi and David Curtius in 2005 in Italy. Okay, so as shown here, it consists of on the top, if you are able to see, so these are pins. Out of this, so these from 6 to 13, these are, we'll call it as a digital PWM pins, pulse width modulation pins here, and thus 0 to 7, these are normal digital IO pins. From 8 to 13, 6 pins are for PWM pins. Okay, and the below there are 6 analog pins. So A0 to A5. So these are, we'll call it as an analog output, analog IO ports. So we can do for inputting towards the particular Arduino. Okay, and here it is a possible for possibility for connecting to your computer with the help of a USB. So this is a USB interface. So you can connect this this is a USB interface. Okay, so you can connect this USB cable to your system, and the other end of this is you can connect it to the Arduino. Then it will blink the corresponding LEDs, and it represents that the system is connected to the Arduino. Okay, so this is a USB connection, and there is one reset pin here. So whenever you are getting any errors, and if you want to refresh the code again, you can press this reset button. Okay, so these are the elements in this Arduino. Okay, so what is the purpose of this here is, here it consists of two supplies here. Some circuits will need the 3.3 volts as a supply, and some circuits needs the voltage as a 5 volts. So if I want to do the TTL gate, So then I can use this 3.3. Then if I want to do the suppression, I can do the 5.5 volts also. Okay, so these are the popular Arduino boards, but the TinkerCAD supports only UNO R3 board. That is what we have seen in the TinkerCAD. Okay, so there are the other popular boards. By using that, we can do the IoT projects. One is Arduino Micro. The other one is Arduino Nano. The other one is Arduino Mega. So it represents the only difference between among these boards is the number of digital IO pins and analog IO pins, but else everything is the functioning is same. Okay, so here but the TinkerCAD, it has only one, so that is we'll call it as a UNO R3 board. Okay, so if you want, you can see here it is specifically written as, I'm zooming it. So this is a TinkerCAD workspace. I'm dragging this Arduino onto my workspace. So this is Arduino UNO. So this is R3 board. So here it consists of 0 to 13. So that is 14 digital pins. Out of this, from 8 to 13, these 6 pins are PWM pins. And here below, there are 6 pins there here. So these are analog pins A0 to A5. And it consists of two supplies, two type of supply connections. One is 3.3, the other one is 5 volts. And this is a jack they provided for USB connection with respect to your computer. And here it is a reset button. Okay, so this is our Arduino UNO. Okay, so these are the popular other boards, but the TinkerCAD supports only the UNO R3. Okay, so then what is how the code will be generated? So suppose if I write any design prototype in the TinkerCAD, and here there is a possibility, I'll show you, there is a possibility to download this particular whatever the block code. So the block code will automatically converts that code into a understandable C++ code. Automatically it converts it into a C++ code. That file I can save on my computer, and I can open this Arduino IDE for real-time execution. So that is, we'll call it as Arduino IDE. So suppose if I want to do, so as I'm showing here, if I want to, if I have a physical Arduino with me, and if I have a cable like this, so if I connect it to this particular Arduino, and if I have the breadboard and whatever the ultrasonic sensor, whatever the project I want to do, everything if I connect it like a laboratory experiments, if I want to connect anything, so I need, because this is a Arduino, we need to dump some code into this. But TinkerCAD supports the block programming. So, but this particular processor, it should support C++ language. So, but as I told you in the first slide, even the person, if they don't have the programming knowledge also, they can do this sort of projects, right? So how it is possible is, so once you are designing by means of a block code, so this code section will automatically converts. So if you see here, there is a blocks code. So these are the blocks here, and there is a text here. So if I continue, so this is a C++ code. Automatically, whatever the block code you did here, that will converted into a text, and this is a download button. So you can download, and that particular .c++ file you can upload into Arduino IDE. So what is that IDE? We'll call here as Arduino IDE. So there are 6 steps here. The first step is you have to download the Arduino IDE by means of this particular website. So arduino.cc/en/main/software. So this is and it allows us to download this in 3 operating systems like a Windows or this Mac OS or Linux. So 3 versions are there here. Whatever the version is suitable for your laptop, you can download that version. Okay. And the second thing is you have to connect your Arduino to your computer by means of this USB cable. You have to connect to your computer. And third one is you have to install the drivers. So drivers means if it is a depends upon the type of OS we have. And the next one is we have to open the Arduino IDE, and then you have to select what is the type of the Arduino board you are doing the corresponding project. And then you have to select the serial device. So means that in which port my this USB cable is connected to my PC. So that particular port I have to select here. So then whatever the downloaded file, if I loaded into this Arduino IDE, it will the same physically I can execute the same code by means of the Arduino IDE. Okay, so if we don't have this physical physical components, no worry. So we can do the same project by means of the TinkerCAD. Okay, so we'll do one simple project before going to the phase 2. So my question is how to control any particular LED. Okay. So if I want to control any LED, right. So if I want to control any LED, so I need three components. One is what is LED. I'm dragging one LED here, and then I want one switch. I want one switch. Switch should be operated such that if the switch is on, LED should on, like your bulb. And if the switch is off, LED should off. Okay. And if I want to operate this, I require one more device, call it as battery. Okay. Any battery you can use. So how many types of batteries are there in the TinkerCAD and how to test each of the batteries, that we will see it in the next phase. Okay. So first, this is a rough example how to do this connection. Okay. So suppose if I want to, if I see this particular LED, the leftmost cursor, it says that it is a cathode terminal and rightmost one is a anode terminal. And similarly, this is my switch which consists of three leads. The leftmost is the terminal 1 and the rightmost is the terminal 2, and the center one is a common. So that is a ground with respect to that. Okay, so suppose if I connect this to so what I want to do here is I want to connect the anode of this particular LED to the one of the terminal, and negative is so to be a closed loop. What I want to do here is drag this and stop somewhere else. Again drag, again add here. Okay, and the common terminal, what I want to do here is I want to connect it to a negative, and this cathode I want to connect it to this. Okay, so because this is a circuit closed loop, if I want to run this, I have to click on the start simulation. So if you observe this particular switch, it is in off state. So if I drag this towards this side, so it will try to on this particular one. So but it is not on. So because there is some limiting resistor should be there to control the current in this particular LED. So for controlling the high current, what I require is I require one resistor. We'll call this resistor as a current limiting resistor. So we'll call this as a current limiting resistor. I can rotate this and I can remove this lead and place it in between these two. So the anode is connected to the one terminal of the resistor, and the another terminal I am sending it to a one of this. Okay, so like here the anode is connected to one terminal, the another one is given to here, and this negative one I have to given to the, if I rotate this, so keep this, and this cathode terminal I'm connecting this. Okay, and because this is a cathode ground terminal, I'm putting into red color, and all these wires I have to click on this and make this connection as red. Okay, so this is anyhow we'll discuss in detail in the second phase. So this is one circuit. Okay, so if I want to zoom it, so the cursor, you can, by using cursor you can zoom in or zoom out. Okay, so that is possible with the help of a cursor, and once the setup is done, so you can do the start simulation. I'll try. If I move this side, it is in off state. If I move this switch to this side, it is in on, off. Is it clear? So this is once the simulation is done, you have to stop the simulation. Okay, so for this, without any Arduino, you no need of doing any block code. Directly you can do the start simulation. Suppose if I am placing one Arduino to control, instead of 9 volts, if I am giving 5 volts with the help of Arduino, then you have to open this code and you have to construct one block coding. So we'll do the same thing here. I don't want this 9-volt battery, but what I want is I require one Arduino. So get the Arduino here and drag here. Okay, so here I don't require any switch here. So this cathode, I'm connecting it to, cathode is negative terminal. So where I have to connect? I have to connect it to ground. Okay, and consider this color as black wire. And the anode, I'm connecting it to a, here the resistance is also known as the current limiting resistor. So which I have to consider, and suppose if I want to make to, because LED is a output device. So it is giving something to the, from the device it is outputting to the world, right? So what it is outputting? Either the LED is on or off. So I can give this to any of the digital pin here. Okay, and change the color of this. So if I'm connecting, giving a supply with the help of a Arduino for my prototype, then I have to do this code here. So if I click on this code, earlier this is not open, right? So if I click on this open code here, so there is some random data is present here. So that data initially I have to put it into dustbin. So suppose if I want to write any block coding, first of all, I need to know what are the blocks available in the TinkerCAD. So there is an output block. So it is represented in the form of this color, blue color, and there is a input color, input. The color of this, all the blocks related to the input devices is in the form of this color, and the last one brown color. So that is, this is a comment. Notation is nothing but comments. So whatever the, like whatever the comment you want to write, whether you are doing, so step by step for public, they want to understand, you can write the notations, n number of notations in your code. Okay, and this is a control. So control is nothing but all the loops like a if else, while loop, count, and then wait, and if it is a do while, everything is available in this control. And then mathematical and logical operations like equal to, greater than, less than, plus, minus. If I want to do n number of math and logical operations, I can do this math control button. And this is a variables. If I want to create my own new variable, I can click on this variable button. So these are all, we'll call it as a blocks available in the TinkerCAD. So suppose for this example, if I want to write a block coding, so as I told you, so even the person, they don't have the programming skills to write the C++ code, they can utilize this TinkerCAD to write this block coding. So blocks is nothing but whatever the existing defined blocks, we have to drag and place it on this particular rightmost panel. Okay. So first, what is our intention from the design? I want to on and off frequently this particular LED. So 1 second it has to be in on position, the other second it has to be in off position, and it should be in a loop. Okay, iterative loop. So if I want to write, so I can make use of these existing defined blocks. So first, if for your understanding, I am taking notation. In that, I am dragging this comment block and I am trying to write. So what is the intention here? So LED is in off state. LED is in off state. So now what I want to do? So I am connecting anode of this terminal to pin number 3. So I want to set this terminal to the pin number 3. So for setting this, what I have to do? Go to the output terminal. Why we are going for output? Because the LED is an output device. It is not taking something, it is not reading the data onto the device, but it is giving the data, outputting some data outside, right? So we have to go to the output and click on this second one, drag onto this rightmost terminal. So which pin we want to set? Which pin it is connected? To the pin number 3. So I have to set pin number 3. And my intention is I have to keep on for a while of 1 second. So that delay statement is appear in the control blocks. So like a wait statement. So drag that wait and place it over here. So how many seconds? So here if you want to wait for a millisecond, you can write, or wait for a second, you can change this particular values. It acts as a delay. Okay. So then again, what you want to do? You want to off this particular LED. So again go to the output section and drag the second one and place it here and change the pin number, that is 3, and now you want to make it as low. So here earlier it is in a high state and now it is in a low state. Again, I want to keep this in wait of 1 second. So it has to be remain in that position for 1 second. Okay, so this is a simple code to turn on your LED. And now you have to start the simulation. If you observe, LED is in on and LED is in off. LED is in on and off. 1 second it is in on and other second it is in off. Is it clear? Is it clear? Any doubt? Any doubts here? Any doubts? You can text me here. If you are having any doubts, we can. Right. So what we discussed here is completely. So how to do the simple circuit design with the help of TinkerCAD. So for that, we went to TinkerCAD login page and went to the circuits, create a new design. So if I'm not using any Arduino and if I'm supplying this voltage with the help of any DC batteries, DC voltages, then no need of doing this coding here by means of a block coding, and directly I can start simulate that particular design. But if I'm giving a supply with the help of an Arduino, surely we have to write the corresponding block code here. Okay, so suppose if I want to execute it real time, okay, so because I have the Arduino with me, so if I want to do physically I want to run this, I have to connect one LED here, like a pin number 3 positive, I have to connect it with one resistor. So these are 1 kilo ohm resistors, 1 kilo ohm resistor, and this is one LED. If I want to connect it onto the breadboard with my Arduino physically, whether how it is performing, so then I can do it with, but that particular software, whatever this Arduino.cc is a software, we'll call it as a Arduino IDE. So for that, what we require, it doesn't understand this block coding. So what we have to do? So there is, if under this blocks, if I, there is a drop down button. If I click here, there is blocks plus text or text programming. Okay, so text is nothing but it completely, I'm not writing any C++ code, but whatever the blocks I have written for the same thing, it automatically converts those blocks into a C++ code. I'll show you how it is. So click on the text, it will ask you, are you sure? Are you observing? So this is a C++ code. So what we did actually, pin mode. So these are the inbuilt key functions for setting the particular pins as a output mode. Okay, pin mode is an inbuilt function. Which pin we have connected as output? Pin number 3. So, and here in this C++, there are two loops. So normally in C, there is only one loop. We'll call it as a main loop. And whatever the variables we are going to declare, that should be above the main loop, right? So whatever the local variables or global variables will write from the starting, and whatever the main executable code, we have to put it into a main loop in case of a C code, right? But in case of the C++, there are two subloops. One is, we'll call it as a setup loop. Whatever this initial setup we need to consider, all these statements should be in that particular setup loop. And then there is another loop, we'll call it as a loop. So there it consists of the actual working of that particular code. It's like your main loop. Okay, so here what we did actually, first I have selected one output block, like a pin number, set pin number 3 as high, and I waited for 1 second, and again pin number 3 as low. So the same statements here it is given. Okay, digital write pin number 3 comma high, and delay 1 second. So here 1 second, here it is showing it as 1000 milliseconds. Okay, both are same, and this is digital write 3 comma low. So sometime it has to be maintaining low output, so with a delay of 1 second. Okay, so this is your corresponding text. If I want to run it, I have to download this. So beside that, there is a download code button. I have to click here. Okay, and it will give you what is the corresponding Arduino code, and it will be open once you install, because I have already this Arduino.cc downloaded. So it will be automatically, if I click on this, it will automatically open this. So this is my particular Arduino code. So now I can, if you see this, so this is my LED. Okay, so I can connect this LED to any breadboard. I can connect this to any breadboard. Okay, and the negative cathode I'm keeping here, anode I'm keeping here, and this anode I'm keeping one 1 kilo ohm resistance, which acts as a current limiting resistor. I am putting here. Okay. And to connect it to the Arduino has two terminals. One is ground here. If you are able to see, this is a ground. I am keeping it ground in the top. Okay. Ground here. So this is the ground terminal. Okay. And there is a positive terminal, which I can represent it as 5 volts, which is connected to the 5 volts. If you see here, LED is in on condition. Is it visible? Is it visible? Is it visible? LED is in on position. Okay. So if I want to, is it visible? No. So this is your Arduino. I have connected with the USB cable, and Arduino I have used the ground and supply 5 volt supply and connected to the breadboard top and bottom. And here it consists of one LED. Anode is connected to the resistor, and the other terminal I am sending it to the closed loop. So to close that, I'll send it to the lower terminal, and the cathode I'm putting it to the connected to the ground. Okay, and it is switch on this particular. LED is glowing. Okay, so with this, one thing I want to tell. So this here in Arduino.cc, there are some 4 blocks, or 4 keys are there. The leftmost there is one tick button. So as I told you, there are Arduino. One is after downloading. So you have to check that. Go to the sketch and see that whether the file is included. So here, because it is a Arduino Uno, you have to check this. This is the Arduino. Right. This is Arduino. It's already there in the Arduino. So if I want to convert this, first I have to change this board to Arduino Uno. Able to see? This is the first step. And the second thing, I have to connect it to which COM port my USB is connected with this Arduino. So here it is already showing which is connected to COM3. Okay. So these are the two things I have to do first. First, I have to select the corresponding board. Even I have the Arduino Nano also. I'll show you later. So that particular board manager, I have to select what are the corresponding Arduino I'm using for my prototype. Okay. So the next one is port I have to select, which is a COM3. Okay. So once it is done, so that is the this is compilation purpose. So this is to verify your code. First, you have to click on this. Click on this, and this is compilation. If there is the inbuilt errors exist, it will display. So nothing is there. So then this is your upload. So because it is connected to the Arduino, which is trying to write. So this is this. I did not install the drivers. Okay, so okay. So I'll show you. So this is the way you have to connect the particular Arduino to the PC. Okay, so this is the another example how to connect with respect to the coding. Okay, so for that what we require, so if I have any tinkercad, I have to convert these blocks into text and then I have to download, and whatever the downloadable code I have to open in arduino.cc. So then there is a tick mark for compilation. If there are any errors it will show us. Then we have to upload the corresponding code onto the Arduino. Okay, so this is a procedure. So this procedure I have listed here in terms of a 6 steps. So first one is you have to download the arduino.cc. So then you have to you have to install some drivers corresponding to your OS, and then you have to connect your Arduino to the computer, and then you have to open this Arduino IDE. So these are the two important steps you have to do. That is, you have to select what is the corresponding board you are using, that is Arduino Uno, like what we did just now. And similarly, the step 6 is nothing but the select the which port the particular device is connected. So you have to select that serial device. And this is an example without Arduino. This is an example that we did, and this is with example by means of the block coding. Okay, and here if you observe, there are the different already existing blocks are available. That is output block, input, notation, control, math, and variables. Output is nothing but always all these blocks are, if you observe, all these are starting letters are set. Okay, it is going to set something on the particular device. So then the input is always, all these elements are, all these blocks are started with read. So it is something reading from the device. Okay, so then notation is useful to do any comment, and control is nothing but all sort of control loops like a while loop, do while, or if else, for, and wait loop. Wait loop is nothing but it acts like a delay, and then count. So everything is up are there in the control. And similarly math functions, so all the mathematical and logical functions are available with this math blocks. And variables, if I want to use any variable, I can use this particular variable. Okay, so this is the introduction with respect to the particular block programming. Okay, so any doubts in this? So this is the, after downloading, what we have to do, we have to compile this, then upload. So our code will be executed. Okay, any doubt in this? Any doubt in this? So what we discussed here is, the first of all, in the first phase, I want to tell you there are some open source tools available, that is Xbody.io, Visuino, TinkerCAD, FreeZing, and NodeRED. And we are concentrating on the TinkerCAD. TinkerCAD is mainly, there are three uses. One is to design a 3D model, or the other one is to design any electronic circuit, complete circuit, and the other one is to design any code compatible blocks. Okay, code compatible blocks. Okay, so these are the three main uses of the tinkercad. And we have seen what is the sign in procedure. So the sign in procedure is always, if we have the Gmail account, so then we can sign in with the Google. Okay, with our Gmail account. So that is a simple way to get in into this particular tinkercad. Okay, so then what we have seen, then it will open the corresponding dashboard, and left panel it shows the three use of this particular tinkercad. And in between there is a create new design. If I am clicking on 3D design and the corresponding create new design, it will open me whatever the corresponding dashboard of this. So that one will call it as a workspace of that 3D design. So this is a workspace here, and the rightmost we are having some basic shapes, and also there is the particular shape should be hollow or it should be a solid. So we can choose among these particular shapes, and we can customize that particular design, and then we can simulate it. So this is a simulation button. Okay, so once the simulation is done, it will generate some 3D model file, and that so there is a downloadable button, so we can download that and we can design that particular 3D design. Suppose if I want to design any circuits, electronic circuit, I have to go to this section and click on this circuits, create new circuit. So this will open this particular dashboard, and these are the elements, components in that particular dashboard. So here the leftmost one will call it as an icon, and this random name can be changed according to the title of your project. And here there are some icons, so each one is its own responsibility. So the leftmost, it is nothing but to rotate the particular device, and the next one, it is nothing but this arrow mark is for undo, and this is nothing but redo, and there is an annotation. So annotation is nothing but if I want to write something for my future reference, if I want to write something on that device like a LED, if it has to be visible outside for everyone, I have to click here as no. This I button has no, there is an option yes or no, so we have to click on the no. Okay, so it will be, if I open my on my screen, it will be appear, visualize for me, but the outsiders cannot see what I have written, the nomenclature of that particular device. Okay, so that is the use of these two buttons, if I want to view or if I want to hide the corresponding annotation what I have written for each of the component. Okay, so then, and the main advantage of this is we can see the circuit view, schematic view, and also the whatever the components are there, so that we can see here. Suppose I'll show you what are the components for this. So suppose if I see here, this is a circuit view. So if I click on this, so this is my schematic view. Understood? So I can copy this and put it on my documentation purpose. If I'm doing any project, I can put it like this. Okay, so this is Arduino Uno. So the D3 is a digital third pin, which is I'm connected to a resistor 1 kilo ohm, and then it is connected to an LED, and then it is given to the ground. Okay, so this is my schematic view. Circuit view is nothing but whatever the circuit you have designed. And if I want to know what are the components I have used, if I click on the last one, it gives what is the name, which button, how many quantities, what is that component. Okay, so D1, first element, so that is a red LED. The next one is 1K resistor. The another U1 is Arduino Uno. So what is this D1, R1 and U1 is nothing but while you are dragging here, it will tell you what is that element. So suppose if I again drag this, it will show you like Arduino Uno R3 number 2. Okay, so that is a name that is the given in component list. Okay, so this is the use of this, and if there is an Arduino, then it is possible to write the code here. Okay, and one more thing we have to remember is, so earlier I have written the block coding, and to show you I have converted into a text. So how it is going to generate the C++ code. So suppose if I want, what is my original block coding, so if I want to follow the same step and click on the block, it will not generate. That you have to remember. Okay, so some rough is given, so that is dummy answer. Okay, it is gone. Okay, only one way it is applicable. So suppose if I have any block code, I can convert it into a text and I can readily use the text. And with that test, if I want to go back again, what is my first block coding, it will not show us. Again, we have to write the block coding. That is only the one thing we have to remember. Okay, so this is possible with only blocks, or block plus text. Suppose if I have an idea to write the corresponding code for any like a sensor, sensor interfacing or whatever it is, so then I can use blocks plus text or completely text. Even I can write the code with a complete, this will be appear. I can write like if I know the inbuilt functions, how to do this. So pin mode, so that particular third pin is given to high. That is my setup. And similarly, so what I have written here, digital write off third pin to high and wait for 1000 second, 1 second, that is 1000 millisecond. Again digital write third pin comma low, again call the delay. So these are the 4 statements I have to write in this loop. Then I have to end. So then I have to start simulate. Okay, so this will simulate my particular Arduino with how to control the particular LED. Okay, so this is what we have seen from the first phase. Okay, that is the what are all the available open source software, how to log in into TinkerCAD simulation platform, and what are all possible with the TinkerCAD, like a 3D design, electronic circuit design, and code block design. Okay, and what are these workspaces, and what are the each and every element of this workspace, what is the purpose of each and every element, so that we have seen. And we have seen what is meant by an Arduino, so and what are meant by sensors, what are the available basic sensors in TinkerCAD. So that I mean introduction I have given here. And the TinkerCAD supports only Arduino Uno, but there are the popular other Arduino boards available in the market. Those are micro, nano, mega also. And suppose if I want to do it physically, if I have all the components with me, then I required one software, call it as Arduino IDE. We know that, right? IDE stands for Integrated Development Environment. It's like a software to do the same project physically. Okay, so for that we need to follow this 6 steps. So first we have to download the arduino.cc and connect this by means of your cable. So this is your cable, USB cable. Connect the particular Arduino with your system. So then install the drivers like corresponding OS drivers. Then you have to open that Arduino IDE, and whatever the downloaded file, that same you can copy, open here. And then you have to compulsory you have to do the last 2 statements, which board you are using and which serial port the system is connected to the Arduino. So once it is done, then it will be appear like this. This is a editor window for the arduino.cc. So whatever the file that which we opened, so that is pin number 2. This is the particular C++ code, which consists of 2 loops. One is setup loop and setup function and the loop function. So setup function consists of the whatever the predefined variables. So but the loop here, it acts as a main loop. So whatever the controlling, what we want to do, everything we have to clearly mention in the loop function. Okay, so then there is a tick button, use it to compile your code, and there is a upload button, use it to upload the code into your Arduino. Okay, so then there is a automatically the result will appear. Okay, so these are the examples we have seen from here, and thank you. We'll discuss in the after break. What we are going to discuss here is what are all the elements and what is the practical exposure to do the interfacing with the different sensors. Okay, so that is what we are going to do after the break. So by using TinkerCAD, how to write the programming C++ code, and by using block codes, how to do that, or by using C++ code, how to write a big code, that we will see in next phase. So that is after the break. Any doubt in this? Any doubt here? You can text here. Any doubt you are having?
I think, ma'am, there are no further doubts from any of the candidates, as you have explained in so detailed way.
Okay, sir.
So, ma'am, I want to let you know that in this STC, we have participants from all over India.
Okay.
And there is one remote center, means one college has been selected as nodal center, the Purnama
Okay.
Engineering College, Jaipur. So maximum participants are from that institute.
Okay, sir.
And Dr.
Yeah,
Payal
congrats.
Bansal is there as local coordinator for that particular remote center, Purnama
Oh,
Engineering College.
okay, congrats, sir.
So, ma'am, I think we can take now break up to 11:30.
Okay, sir.
So we'll start again at 11.
Yes, sir. So next phase, I'm going to discuss about the physical Arduino. I mean, yeah, I have all the components I have.
Right.
So how to do the physically, how to do that particular Arduino connections, how to view the output with or without the TinkerCAD.
Nice.
Okay, sir.
Okay, so then we'll again start at 11:30.
Okay,
Thank
sir. Sure, sir.
thank you.
Sure, sir. Thank you, sir.
So, dear participants, if you are disconnecting, kindly connect back via 11:25.
Good afternoon, Padma ma'am.
Good afternoon, ma'am.
Ma'am, am I audible clearly?
Yeah, ma'am. You're
Okay.
audible perfectly.
Shall we start or we'll wait for 2-3 minutes as you say?
No problem, ma'am. We'll start, ma'am.
Okay. Good morning to everyone, all participants. This is the fourth day of the short-term course program, and we have with us our eminent speaker, Dr. C. Padmaja from JNIET Hyderabad. As ma'am was with us in the first session also, so the introduction is not needed yet. So without taking much more
Yeah.
time, I'll hand
Yes.
over the platform to you. Ma'am, over to you. Please start.
Thank you, ma'am. Thank you. Yeah, in the first half of the morning session, what we discussed is I just introduced what is the TinkerCAD and what are all other open source tools available and how to sign in into the TinkerCAD simulator and what are all the essential component list that is there in the TinkerCAD and how to do the initial programming by means of block code and how to convert that block code into text code and what is the corresponding IDE we have like a Arduino.cc. So that IDE, how we have to do that with the initial code we explored in the first phase of the particular FDP. Okay? So now I'll share my second phase of this FDP. So here the second phase completely I planned according to whatever the basic components we have. So each and every component we have to look into what is the purpose of this and how to test that particular component and how to write the block code for that. Okay? So in the second phase, what I planned here is this is the contents of this phase 2. So first, I have seen, as I told you, there are all the list of components available in the TinkerCAD. So many input devices are there, and so many output devices, and the normal, the side by side, some other which are helpful for designing, customizing your circuit like a battery, resistor, capacitor, inductor, relays. Everything are there as a part of the component list, right? So in the second phase, what I want to do is I want to take each and everything, every component onto my workspace of my TinkerCAD and how to test that particular one and what is the purpose and what, if I change that element, what is the reflect on the output of that particular system design or prototype design. Okay, so we'll go one by one. So for the first one, battery testing and what is the use of multimeter. So that we will see with respect to the TinkerCAD. So this is my TinkerCAD version. So if I want to create a fresh one, going back to after clicking this TinkerCAD, I'll come to this, the first dashboard screen, right? So here I want to take any new circuit. So go to the leftmost panel circuit, click on that circuit and then click on the create new circuit. Right? It will open this particular workspace with the components available here. So the first topic here is what are all the available batteries in a TinkerCAD and how to test this. So first I write in the search space battery. Okay. So how many batteries are there? There is a 9-volt battery. There is a 9-volt battery. I am dragging here, and there is a coin switch battery, and there is 1.5-volt AA battery. So these are the batteries available in TinkerCAD. Okay, so here if I click on this particular 9-volt battery, so suppose if I want to test it, so how can I test this particular 9-volt battery? So first I'll rotate this into the understandable code. So then if I have any LED, drag onto the screen here. And I told you the leftmost one is a cathode and the rightmost one is a anode, right? So anode I'm connecting it to the positive terminal and the cathode I'm connecting it to the negative terminal of my battery. Okay, and to show the difference between the wires, negative connection, I'm putting it as black, and click on that particular wire and change the color of that wire. So because this is a VCC, I'm changing this. Okay, so suppose if I'm not using any Arduino, just like that we can go to the start simulation and test it. Okay, right. So I did a start simulation, but I got some error. So my LED is somewhat, it is showing some error. So what is that error? If I place my cursor on that LED, it is showing that the current through the LED is 915 milliamps, while absolute maximum temperature is only 20 milliamps. So then how to limit this maximum current, 915 milliamps current? How I have to control this high current means I have to stop this simulation and remove this positive terminal and select one resistor. Select any resistor and rotate this. Rotate this and connect one of the terminal to the one end of the resistor, and the another end I'm connecting it to the positive terminal. Earlier I have directly connected. Now I am putting some resistor in between my anode terminal with respect to the positive connection of my battery. So now I try to do the simulation here. Right? So what are the observations here? So now this LED is glowing, right? So with the support of 9-volt battery, right? And so if I click on this particular resistor, okay, if I click on that particular resistor, it is showing some window. What is the name of that? And how much is the resistance value? So what is the resistance value? 1 kilo ohm. So if I change that to ohms, what is the error? Again, I'm getting the error. So if I want to overcome, if I change it to 500 ohms, then the particular LED is glowing normally. So with this, what we can observe is the intensity of that LED can be changed with the help of the changing the resistance value. Okay, so if the resistance is too high, then the current is very, very low. So then corresponding intensity is also very, very low. So that is what we observed with a 1 kilo ohm resistor. If the resistance is 1 kilo ohm, so again I'll change this to 1 kilo ohm. You just observe again. If it is a 1 kilo ohm, changing this. If this is a 1 kilo ohm, and if I want to again start simulation, observe the intensity of this LED. It is somewhat very dull in nature, right? So suppose if I change this to still 2 kilo ohms, I'm still changing this. What is this LED intensity? Still it is very in dull color, right? So suppose if I change this to only ohms, so like 500 ohms. Okay, so then now you observe what is the intensity of this. So this intensity is very brighter when compared to the 1 kilo ohm resistor, right? So here the resistance value have decreased, so the current is the current flowing is very, very high. So then the corresponding the intensity increases, the current also increases in that particular closed loop. So thereby whatever the resistance value, we have to keep it as low as possible. So this is the first observation, and this is the first case 1, how to test the 9-volt battery. So how to test the 9-volt battery? I have to give some connection with a LED. Okay? And similarly, there is a coin battery. So say this is a coin battery CR2032, which is of 3 volts. Okay, and there is one AA battery like a 1.5 volts. If I click on this 1.5, it is giving some other window here. Have you observed? So here the battery count is 1 battery and the type of battery is AA and the built-in switch is no. So usually the particular battery is having inbuilt switch. So if I press it as S here, so there is a on off switch here. So if I connect something, it will be going to on or off. Okay. So as of now, I'm keeping it as no here. So suppose if I want to, here there is only 9-volt battery and 3-volt battery and 1.5-volt battery. So suppose if I want to make it as 4.5-volt battery for my respective design of the circuit. So then how to create the 4.5 volts? By means of increasing the count of the number of batteries here. So suppose if I increase 2 batteries, so 1.5 plus 1.5, it equals to 3-volt battery. So suppose if I increase the 3 batteries, it is equal to 4.5. Okay. So likewise, I can increase the number of batteries, but the maximum batteries I can increase here is only 4 batteries. Okay. So these are the available batteries. And similarly, if I want to test the same 4 batteries, or if I want to test only a single battery. Okay. So then how to do this? Anode, I have to connect it to the resistor one of the terminal and resistor another end. I have to connect it to the positive terminal and negative directly I am sending it to the negative of this and change the color of this to black. So now you simulate this. It depends upon the resistance value. Okay. So here for that what we have to do here is this circuit I have to clear it off, then only the other one will work out. Okay, so now you do start simulation. LED is glowing, but it's not visible properly. Okay, so if I want to clearly see, I'm changing it to 2 batteries. So now you observe start simulation. Even the color of this LED is very, very dark in color. So you observe carefully, LED is glowing. Okay. So it depends upon the amount of applied voltage. So suppose if I increase this to 3 batteries, so how much voltage I have given? So that is 4.5 volts. And still this intensity is somewhat in dark color. If I want to increase this intensity, current flow, if I want to increase, I have to decrease this resistance value. So I can decrease this to 500 ohms. Then you observe this LED is glowing with a brighter intensity. So this is the way to test this LED with respect to the batteries. So how many batteries we are having? One is 1.5 AA battery. So then 9-volt battery, then 3-volt coin switch battery in the same operation. Okay. So that is what the first topic is. So battery testing with the use of multimeter. So we know that what is a multimeter? Multimeter is a device you can test what is the voltage, or you can test current, and you can test resistance of that particular device, right? So you can test any of this with the help of the multimeter. So suppose if I want to test any battery with the help of the multimeter, first I am sending this to only 2 amp, and then this wire I'm disconnecting and putting this here. And the anode of this terminal is given here and cathode is given to this. Okay, so I have given one circuit here. These are the batteries. Okay, so if I want to test with a multimeter, So I am testing this with LED and with one resistor here. Okay, so the same way I connected, but here I did not connect the LED. Okay, so here connect this positive to one resistor and the resistor another end to this, and the negative terminal directly connect to the this one. And if you click on this multimeter, you can change the mode of this, whether you want to operate to calculate the voltage of this connected circuit, or the current flowing through that particular circuit, or how much is the resistance you have used. So right now I am interested to calculate the voltage. So keep the mode as voltage, then start doing the simulation. Understood? So it will give the reading of how much is the voltage you applied in that circuit. So 1.5 plus 1.5, it is 3 volts. So suppose if I click on this and change it to 3 batteries, what is that voltage? 1.5 into 3. So that is 4.5 volts. So suppose if I click on this, increase the batteries to 4 batteries, it gives the corresponding voltage as 6 volts. So this is a circuit used to test the batteries along with the multimeter. So how much is the voltage? Okay, so earlier I have given, instead of multimeter, I have set one LED, and how much is the amount required to on that particular LED in terms of the intensity purpose. So if the resistance is too high, intensity is very, very low, and to keep the intensity high, we are making the resistance to low. Okay, so and in the second way, I can use the multimeter to calculate what is the amount of voltage I applied here. Okay, similarly, if I want to test the current, okay, how much amount of the current is flowing. So you know, Kirchhoff voltage law, that is V equal to IR. So from that, I is equal to V by R. So how much is the voltage you kept here? So suppose if I keep as 1 kilo ohm, then it is easy for me to calculate. So 1 kilo ohm is the resistance. I is equal to V by R. So what is V here? V is your corresponding applied voltage, that is 6, divided by what is the corresponding resistance? 1 kilo ohm. So then how much, theoretically, how much is the current here? 6 by 1 kilo ohm is nothing but 6 milliamps. We will test it. Okay, how it is showing the current value. Okay, so for that, what we have to do here is same circuit. So change this mode to ampere. Change this mode to ampere. So what it is showing? 5.99 milliamps. So 5.99 is approximately 6 milliamps. How we got this? I is equal to V by R. Applied voltage is 6 volts divided by 1 kilo ohm resistor. So that is 6 milliamps. Approximately it is showing that. So this is a testing of batteries with respect to the multimeter. Okay. And suppose if I want to test resistance. So what can I do? I'll remove this batteries, and one of the terminal of this resistance I've given to the positive, and another terminal negative of this I'm giving it to the another terminal of resistor. This is a simple circuit to calculate how much is the resistance value. For that, you have to change the mode to resistance, and then you start doing the simulation. What is the value it is appearing? 1 kilo ohm. So in this first session, what we have seen here is, first topic, what are the batteries available in TinkerCAD? That is 1.5 AA battery, 3 volt coin switch battery, 9 volt battery. And how to test it using LED, and how to test them using multimeter. So that is what we have seen. So using multimeter, we can test the voltage across the circuit, or the current flowing within the circuit, or the resistance calculation by using the multimeter. So that we have considered in this circuits here. So this is one circuit. And if I want to test the particular battery's current, I have to change this mode to ampere. Or if I want to calculate the voltage across the circuit, I have to change the mode to voltage. So this is the first, basic concept to know how the particular component is able to test. Okay, so that is the first one. And what is the second topic I'm going to consider here is what is the testing of LED. So we did that testing of LED. Again, I will do here LED. So for that, first I have to create a new workspace. So that is LED, and I require one resistor. And if I without Arduino, if I want to show you how to control the LED, I require one battery. Okay, so that battery might be anything. So 1.5 volts battery. Okay, so or 3 volt battery, whatever it is. So we have seen already. So the negative, anode, I have to put it to one terminal, and the another end I have to send it to the positive node, and this cathode I have to directly short to the negative terminal. Click on that square box, drag, again in the another square box, click over there. Okay, so then if I start doing simulation, it is on position. So the LED is in on, but the intensity is low. Okay, so this is without Arduino. So for this, no need of block coding required. Okay, so suppose if I want to do the same LED control with the help of Arduino, I have to remove this and I have to get what is Arduino. Okay, so that Arduino I am dragging here. So the positive terminal, that is anode, is given to the resistor, and resistor another terminal. Because it is a digital output, I have to connect it to any one of the digital pin. So that is, I have connected to fourth pin, and the negative pin I have to connect it to ground here. Okay, so this line is a positive line. If I want to show the difference between these two wires, I can write this as red wire. Okay, so this is my circuit. So for this, I have to write the code. Already we have written some code in the last first phase. So for your reference, I am writing again. Okay, so what is the first thing? If I want to do the block coding, so what I have to do? So first I have to set the particular LED pin to the pin number 4. So how to write this? So I am set that particular pin. So it is a output pin. Go to the output section and drag this onto this space here. Okay, and select the pin number as 4 here. And I want to set it as high. So first time it is in on condition. How much time it has to on? It has to wait for a delay by a 1 second. Okay, and the same thing has to be repeated with a LED off position. So select the same pin number and make this as a low pin, and again select this wait terminal for a while of second. So now our code is done. Okay, so suppose if I choose the under blocks plus text, it is parallelly giving what is the corresponding code, convertible C++ code parallelly. Okay, if I click on only text, it will be giving only the text C++ value. But if I click on blocks plus text, it will be giving what is the code we have written, what is the comparable C++ code generated by the software itself, that is appearing on the rightmost panel. Okay, so now you can start simulation here. Right, now you can do the start simulation. For a while it is in on condition, and in another 1 second it is in off. So it's continuously in a loop. So we are calling that Arduino.cc has two type of loops. One is we'll call it as a setup function, and the another one will have we are calling it as a loop function. Okay, loop here is it's like a while of one loop. So while of one is nothing but it is a continuous infinite loop. Continuously it is on for 1 second, off for 1 second. It is in that particular loop. Okay, so in such a way that we have written this. So this is how the particular LED is able to control with the help of with Arduino or without Arduino. So that is what the testing of LED. So what we did here for testing of LED, without Arduino, this is a circuit, and with Arduino, this is a circuit. That is what we have seen, right? So what is the next topic? So that is intensity control of LED. Already we have seen that as the resistance value goes on increases, intensity less. And if I decrease that resistance value, then only I am able to see the clear intensity of that particular LED. Okay, so then we'll go to the next one, that is testing of motor. So how to test the motor? So this Arduino has one element. I'll remove everything. If I want to delete the components, click on the component and delete. Press on delete. Okay. Now, so I want motor. What is the purpose of this motor? The Arduino is consists of one DC motor, that is this, and this can be used to find out what is the speed of that meter or motor, or what is the how many number of revolutions it is making per minute. So that all calculations we can do with the help of this DC generator available in TinkerCAD component list. Okay, so this is one, and if I want to test this motor, so I require one, right? I require one resistor, okay, and one battery, one battery, 9 volts battery I am putting, and now I am trying to connect. So how I am going to connect this? So by placing one resistor and one switch here. Okay, so I require one more switch here. Switch here. I am dragging that onto the screen. So if I am using this particular switch, I can directly use this 1.5 AA battery, because this 1.5 AA is inbuilt, it is having the switch. So suppose if I am using the inbuilt switch, no need of the external switch here. Okay, otherwise I require one switch externally to connect the particular circuit. As I told you already, so this switch is consists of 3 terminals. The middle one is a common, and the other 2 sides of this middle is we'll call it as a terminal 1 and terminal 2. Okay, and this is your DC motor, positive terminal, terminal 1, and this is your terminal 2. So take one of the terminal and connect it to the any one of the terminal, and this terminal I'm sending it to the particular battery positive, so this is positive. Okay, and negative I want to connect it to this negative terminal, and I want to change the color of that. So this is my circuit. Okay. So because here we don't have any Arduino, directly I can do the start simulation. Okay. And nothing revolutions. I am zooming here. There is no revolutions, only RPM here is 0. So because the switch is in off state. So suppose if I am putting into, if I drag this to this side, switch in on condition, it start showing what is the number of revolutions that the motor is doing per minute. So that is 2974 RPM. Okay, this is how the motor can be tested manually. Okay, so we have to connect a switch and a battery, and the battery, if that particular switch is in on condition, the motor start rotating, and the number of revolutions it is taking per minute with a 1.5 volt battery is 2974. So suppose if I want to increase the speed of the motor, so what is the possibility? The possibility is whatever the applied battery voltage, I have to increase. So suppose if I increase 2 batteries, how much is the voltage I applied? I applied around 3 volts, 1.5 plus 1.5, 3 volts. Then you observe what is the number of revolutions, 5902. So what you observed from this with respect to DC motor? If I am having 1.5 volts DC, voltage, battery voltage, the number of revolutions is 2974, and if the battery voltage is increased to 3 volts, then the number of revolutions per minute is also increases, and it gives us a 5902. So suppose if I click on this battery and again change it to 3 batteries, so it constitutes 4.5 volts. So then how much is the RPM? 8784. So means that as the voltage increases, RPM also increases, thereby speed of the motor increases. So that is the point we have to grab from this analysis. Okay. So as the voltage keep on increases, the RPM increases, thereby the speed of the motor is also increases. So this is the way you can test your corresponding motor. Okay, and similarly if I want to test how much is the current that is flowing, same thing, one multimeter we have to keep in between the motor and that particular switch. Okay, in between one signal should be there, one multimeter should be there, and the output connections else are same. So here as the voltage increases, the speed also increases same as it is, and here the current also tries to increase much more. Okay, so this is the interfacing of the motor. Okay, so now we will go to one application with respect to LED. Okay, so LED, one of the application is, we'll call it as a traffic light signal. So how to design that particular circuit using the TinkerCAD. Okay, so everybody, we will go to the TinkerCAD. Okay, I'm doing the start simulation. I don't want this circuit, so I'm removing all the elements. So what I want to do here is, I want to do the traffic light control. So usually we will see there are 3 LEDs. One is red, yellow and green. And each LED is of glowing duration is, that pulse width should be 3 seconds. After 3 seconds, first red will be glow. After 3 seconds, green will be glow. So after 3 seconds, yellow will be on condition. Okay, so that is what our idea behind the design of this traffic light. So for that, what else the components required is, I require one Arduino. Keep and drag it here, and then I require LEDs. How many LEDs I require? 3 LEDs I require. So drag 3 LEDs. Okay, so to place this, I require one breadboard. I require one breadboard. I require one breadboard. I'm keeping this here and placing these 3 over here. And how to change the color of that LED? All are here red in color. So if I click on that, it asks you the name and color of that particular one. First one, it should be a red color. Second one is in yellow color. And third one, click on that particular LED, go to the color and change it to green. So these are the 3 LEDs. And as usual, we know there should be some current limiting resistors, right? So at each of the anode section, so this is one resistor and this is another resistor and this is another resistor. Okay. And what else we require? So I want to do ground connection. I want to do the ground connection to this line of the breadboard. You know how the breadboard will work, right? Here the connection will be, current flow will be in a parallel dots, but here the top 2 and bottom 2, the current flow will be in series. Okay, so I am putting here, and each negative, that is each cathode of each of the LED, I am connecting it to ground. Okay, so ground I have given from my Arduino. Okay, so and here yellow cathode is also grounded, and this green one is also grounded. And what we have to do with the other side terminals of this resistor? One side I am connected to anode of the each of the LEDs. The other side, because already I told you LED is in the form of a output device. So we have to use only the digital outputs. So connect the another end of this resistor to a 4th pin. I am connecting 3 pins of the digital pins here. Okay. So first one I am connecting to a D4, and the second LED green I'm giving it green color. What is this? This is yellow, and we are giving it to 3rd pin, and the last one I'm sending it to pin number 3. So what are the observations we did here? So to implement the traffic light signal, I took one Arduino for giving the supply, and for putting all the digital outputs. And we have 3 LEDs, 3 resistors. All the anodes of this LEDs are connected to a current limiting resistors, and the other end of this resistor I am sending it to a one of the pin of the digital pin of your Arduino. So red is connected to, is it visible? Red is connected to 4th pin. Red is connected to 4th pin, and yellow is connected to 3rd pin, and green is connected to red pin. So with this my circuit is done. Okay, but since I am using this Arduino, I have to write the code, block code. So we will prefer the block code. Okay, so once I click, how I went for this? If I click here, code button, click on it, it will open. So initially it will give you some junk code. Drag that and put it in the below rightmost bottom corner. There is a dustbin, throw it there. Okay, so now we will freshly write the code for this. So first I'll start with the annotation for your reference. Okay, so set pin. So first what we have to do? First time red pin should be in on condition. So red light is in on condition. Set red LED in on condition. So this is my comment. Okay. So with this, how to set this? I have to go to the output block and select the second one, set pin, and join to this existing one. Okay. So now I have to indicate what is the number of that particular pin. Red is connected to pin number 4. So I'm placing this pin here 4. Initially, the red should be in on condition. Okay. So how much time? So go to the control, select the wait block and put it below here. How much time? Practically, they're maintaining 3 seconds. Okay. So next, after 3 seconds, next green should be in on condition. Usually the traffic lights. So first red will be there. After some time, green should be in on condition. Okay. So what is which pin I have connected here? So I have connected to second pin for the green LED. So but before that, I have to take care about the red LED. Already because it is in on condition, I have to make it as off. Then I have to concentrate on this green LED to make it as on condition. Okay. So for that, what we have to do? So again, go to the output and select the next. This is a set pin and drag and drop over here and make this pin number as 4 to low. Low means that the particular signal is in off state. So whatever the LED, it is in off state. So red is in off. So immediately it has to take green LED should be in on condition. So again take this, select the green LED pin, that is pin number 2 to high. Okay, so now green LED is in on condition. How much time it should be in on condition? Again, same rule as wait statement I have to consider around 3 seconds. Around 3 seconds. Now green is in continuously on condition for a 3 seconds. After 3 seconds, green should be in off condition. So what I have to do? Go to the output, select the next one. This is set pin and set the corresponding pin as roll number, pin number 3, not pin number 3. Green is in red pin, second pin. So make that second pin, which already we have put it as high. Now I have to make it as low. Okay, so the green pin is in off condition. So now I have to concentrate on yellow. So yellow, again drag this. Yellow, it is connected to pin number 3 here and set it as high. Okay, so once it is there, so then again I have to maintain this on condition for a while of 3 seconds. So is it done or still anything we need to include? Can anyone give the clarity? Is that code is sufficient or still we need to add some more lines? So what I did in this code is first fourth digital pin which is connected to the red LED is in on condition. So it will be keep on condition over a time of 3 seconds. So after 3 seconds, I want to try to off this red LED by means of selecting fourth pin to low, and then I have to start blinking this green LED. So green LED, since I have connected to pin number 2, so I have connected to set pin 2 to high. Okay, so and this green LED should be continuously in 3 seconds on condition. So I have called this wait loop for 3 seconds. Okay, so once it is done, so what we have to do? That green LED should be in off position and then orange LED or yellow LED should be in on condition. So, but where is the yellow LED is going to end? So that is end or here. So go to the set and select this and join this. So here we have to include, here I didn't include the yellow to be off condition. So here yellow is in 3, third pin, and it should be low, and then now it has to start repeating this particular loop. So this is what the code for traffic light. If I want to change the project name, I can click on this random name with a traffic light. Okay, and if I click somewhere else, that name will be appeared as of that particular workspace as traffic space, traffic light. Okay, so this is the basic circuit, and the corresponding code we have written here. Okay, any doubt in this code? Any doubts in this code? Any doubts? Okay, so here if I run this, I'll zoom it. Observe, after red, green is in on. After a while of 3 seconds, yellow is in on. Then red is in on, and red is in off. Then green is in on, and green is in off, and then yellow is in on, and yellow is in off. Red is in, sent to the green. Okay, so this is what the traffic lights are. Red, any doubt in this? I'm waiting for your response. This is a traffic light example. Any doubt in this? Okay. So this is once it is done, so you can stop simulation. This zoom in or zoom out can be done with the help of cursor. Okay. So this is your traffic light example. So this is the next item in my agenda. So that is traffic light. And then I want to tell you finally how this is converted into Arduino code. So Arduino code, if I want to convert this into Arduino code, how to write? Go to the code section, and under block there is a blocks plus text. So whatever that code, you have to download it and open it on a arduino.cc IDE. Okay, so that is what you can do. So that is the next topic. And so this in this Arduino IDE there are main two loops. One is setup function, the other one is loop function. Loop function acts as a main loop here, and this acts like a while of one loop, so which continuously run repeatedly. So that's why if I am able to run this particular traffic light, it is in a while of one loop, so that is infinite loop. So continuously one after other it is in running mode, so according to the code that we have written. Okay, so this is about the traffic light. Any doubts here? So this is the second phase which I have planned, and coming to the third one, so this third phase completely I want to give an exposure to what are all the sensors available. In the first phase I have declared what are the sensors and what is the principle behind it, each of the sensor, right? So we have seen from the TinkerCAD, there are some sensors, those are listed here. One is LM35 or 36 temperature sensor, ultrasonic sensor. So then LED intensity you can change by means of a potentiometers. Okay, and then there is a light sensor using the LDR, and then there is a flame sensor interface with the PIR, and then I've given some exercise questions for your practice. Okay, so here before going into the how the sensor is interfacing with your Arduino, before going to that, first of all we need to know about what is the each of the sensor denotes. Okay, so first if I take the LM35 series, so each of this LM35 sensor consists of three terminals. The first terminal is VS, so that is voltage, and that is input voltage, and V out is the output voltage, and the third pin is the ground pin. So suppose if I see this on a TinkerCAD, Okay, so what is LM or temperature sensor? So this is your temperature sensor. Okay, it consists of 3 leads. The leftmost one is the supply voltage, input voltage, and this is output, and this is the ground. Okay, so this is your temperature sensor. Okay, this temperature sensor, I already listed what is the principle behind it, right? So here, because it is connected to voltage, right? So the output voltage keep on increasing for every 10 millivolt degree temperature increases. So for every 10 degree temperature, so there is a corresponding voltage. So voltage is converted to temperature, and temperature is a mutually understandable language like a Celsius or Fahrenheit. Okay, so here one more thing, this ADC is having the internal ADC. Sorry, this Arduino is having the internal ADC. ADC is analog to digital converter. Whatever the temperature it is reading, that value it is converting into a 10-bit ADC, 10-bit digital value onto that particular screen. Okay, so that is the main advantage of this 10-bit ADC. So, and there are the different variations of this temperature sensors. One is LM35D, that is a new type, and the LM35A, LM35C, and LM36. So why the difference in these variations of the different temperature sensors with respect to how much voltage or how much current it is varying with respect to the corresponding change in its temperature. Okay, so the first one D, it is useful only for the domestic purposes, and the temperature range for that sensor is 0 to 100 degrees centigrade. Okay, so this is like your local thermometer. Okay, so it used to use there is a temperature sensor within that, so that is used to measure only the temperature is in between 0 degree Celsius to 100 degrees Celsius. Okay, so that is what is the nomenclature of that temperature sensor? LM35D. Okay, and there is one more, we'll call it as a LM35A, but the purpose of this is used in military. So why? Because we are using this is to get the sharpest values. Okay, so even at the negative side or at the more than the 100 degrees centigrade. So that is minus 55 to 155 degrees centigrade. So this is the temperature range of the A. And similarly, temperature range of the C is nothing but, so minus 40 to 110. And there is one more, that is LM36, which is equal to minus 55 to plus 150 degrees Celsius. Okay, so this is about the temperature sensor, and we need to know how it is going to convert by means of a 10-bit ADC. So suppose if it is reading some value, analog value, how it is converting that into digital value. So because the ADC is a 10-bit ADC, so we'll call that data as a 2 power 10. So that is what is the value of this digital corresponding value? 1023 letters. Okay, so that is for every 5 volts of the input, it is going to generate the digital value of 1023. Okay, so and we need to know how it is going to convert the Celsius to Fahrenheit, or if there is a Fahrenheit, how it is converted to Celsius. So that is the another part. So the flowchart how this temperature sensor is working is, we have to read the analog pin A2. So here I have connected one circuit. Based on that I have written this. I'll show you. The circuit here is this. Okay, is it visible properly? So this is a particular temperature sensor. As I told, there are 3 terminals here of the temperature sensor. 3 terminals, and the leftmost terminal is a VCC, and rightmost terminal is is your terminal 2 here, and middle one is your analog input. Okay, so the analog input, you can use any one of the 6 analog inputs, A0 to A5, and this positive I am connecting it to 5 volt of this Arduino, and negative I am connecting it to the ground terminal. And to limit the heavy high current, we are attaching 3 LEDs. We are attaching 3 resistors with respect to 3 LEDs. So there is one option in TinkerCAD without using 3 LEDs always, all the time, like what we did for a traffic light. 3 LEDs we have chosen, 3 resistances we have connected to the anodes of their particular LED, right? So instead of that, there is one element, a component in this TinkerCAD, that is, we'll call it as a tricolor LED. So if you want, I'll show you. Tricolor LED. So tricolor LED is nothing but red, green, and yellow are there in this particular leads of this tricolor LED. So if I zoom it, it will be shown. 1 second. So, is it visible? This is a tricolor LED. It consists of 4 leads. One of the second lead is in ground connection, and the first and last through are in connected to the corresponding resistances. Okay, so this is a circuit we can design for this, and for this it is easy to write the corresponding code for that instead of doing a block coding. Okay, so you know, the each and every LED, whatever the setup connections, we have to put it in a setup function, and what is the main how the working of the code will be written in the loop function. Okay, so first initially how the working will be. So if you see carefully here, so the middle one of the temperature sensor I have connected to pin number A3. So A3 is a analog pin 3. Okay, so and this tricolor, the is positives, all positives are connected to the another terminals, digital inputs of this particular Arduino. Okay, 4 3 2. Okay, so this terminal I am connected to 4, then 3, and this 2. Okay, so this is the final connection of my temperature sensor. So the same thing can be explored with the TinkerCAD of our TinkerCAD. So let's go to the TinkerCAD. Okay, and select one Arduino. Select one Arduino and drag here. So the earlier connections, I am removing all. Earlier connections, I am trying to remove all the resistors. I want to do it freshly. Right. So this is my Arduino. So what else is required for my purpose? LM35. So LM35 is select this as a temperature. So it will show you LM35. Okay, keep here. Okay, and take one breadboard. Simultaneously, please, you people also do it along with me. So take one breadboard. Okay, and instead of 3 LEDs separately, what I am using here is to introduce you the another component. There is a tricolor. Even if you type LED, it will show you. This is your tricolor LED. Okay, this is your tricolor LED. So what we have to do? I have to consider 3 resistances. 3 resistances. Okay, so in this, the leftmost one is a red color. If I show the cursor over there, it will show you what is the color of that. This is a red color, and middle one is a cathode ground terminal, and the next one is a blue color, and the last one is a green color. So this is a tricolor. So usually, to avoid the confusion, so the second button I am dragging and putting here, connecting here. The negative is connected. So to maintain it as a ground terminal, and taking the help of the Arduino and make this as a negative terminal. Okay, and all the positives of the LED anode terminals are connected to 3 different resistances. 3 different resistances. Okay, and the output, I mean the other terminal of these resistances, I can connect it to digital pins. Okay, what are the digital pins I am considering? One is 4, and the next one is pin number 3. The last one is I am connecting it to pin number 2. Okay, so this is what my design is. So this is what I have written there, right? So I'll so this is what my system is, right? So now I have to connect the temperature sensor. So where is the temperature sensor? This is the temperature sensor, which consists of 3 leads. The leftmost one is a power. So make this connection as towards a positive. I'm considering this as a positive, and take 5 volts. And connect it here. Okay, and consider this as a supply value, and this is also a red in color. Okay, so what is the next terminal? Next terminal is a analog value. So analog value, I have to consider it to one of the analog pin. So any one of the analog pin I have connected to A1. Okay, so then what is this last terminal? Last terminal is your ground. So I can send it to this, and make the color change of that wire is black. So this is my temperature sensor. So the temperature sensor, I have connected it to the positive terminal. Leftmost is positive, and middle one is your temperature sensor or analog value, and the rightmost, it is nothing but the ground terminal. Okay, so for this, what is the circuit? Right, so what is the code for this? So first, what we have to do here is, this is the corresponding code. So our intention here is, I've changed the application here. So one is, there are 3 different type of LEDs. The 3 I'm showing the variance with respect to by using the tricolor LED. Okay, so whatever this code, I'll just copy this and I will explain now. Okay, so I'll copy this and put it into your TinkerCAD. Go to the code section. Under code, you go to the text section. Okay, and whatever the existing one, you delete it and copy whatever the code I'm showing you. So what this code is refers. So this temperature sensor, as we know, this is used to detect the temperature as the particular voltage is changing. Okay, so here if I want to represent the temperature changes, whether it is hot or cold or it is moderate, so I am using three LEDs. One is blue, green and red, and these three LEDs are connected to pin number 2, 3 and 4. Okay, so pin number 2, 3 and 4, and here there is a serial begin. The serial begin is nothing but to communicate with respect to the serial communication RS-232. There is a window where you can output the readings of that particular circuit after simulation. Okay, so I will starting this serial begin of 9600 baud rate. So and select this as pin number A2, but here I have used this as A1. So I am changing this value as A1 as my input of my temperature sensor. Temperature sensor, the middle one is an analog value which I connected it to A1. So I am changing this as pin mode A1 to input, and I am starting the serial begin, serial communication with a 9600 baud rate, and pin mode 2, 3 pins are connected to 3 LEDs which are in output state. Okay, so these are all the setup statements. Then coming to the loop statement, initially what we have to do, whatever the value that the temperature sensor is reading from the button A1. So here what is the button I have connected? This is A1. What is the value it is reading? So once it is connected, so it is keeps on reading what is the temperature value. So first we have to read what is the value. Then using the 10-bit ADC, I have to convert this analog value into a digital value. So how I am able to convert this is whatever the value it is reading divided by 10024. What is this 10024 refers? 10024 is nothing but because it is having the output data. So that is 2 power 10 is nothing but 10024. And the maximum voltage of this Arduino is 5 volts into 5. So this is a formula to get what is the corresponding digital voltage value. Understood? Temperature sensor used to convert the temperature into corresponding voltage by means of 10-bit ADC. Digital value it is going to represent. Whatever the value it is reading from the analog read pin A1, that divided by 2 power 10, that is 10024 into the maximum voltage applied voltages into 5. So that is the voltage you calculated. Okay, so suppose if I want to get only a Celsius temperature, so what I have to do? So this is a formula for this Celsius temperature, and to convert the Celsius into Fahrenheit, I have to multiply the Celsius voltage into 1.8 plus 3 plus 32 is the general formula to convert the temperature Celsius into Fahrenheit. And everything I want to print on a serial monitor. So with a starting value, starting nomenclature as temperature colon, and whatever the value it is reading and converted value, everything I am printing on the serial monitor. Okay, so then temperature Fahrenheit also it is printing. Okay, so now our intention is if temperature is less than the cold value, so I have given the cold temperature is 75 and hottest is 87 values. Okay, if the temperature is less than 75, so less than 75 it is very very cold. So which type of LED should be in on condition? I want to suppose to on the red LED. So that is pin number 2. So that is in on condition. The other two are in low condition. And that is a and it will show print a line in the serial monitor as low temperature. And similarly, this is if. Else if temperature is greater than hot, so what it is? Fourth LED, so that is green LED should be in on condition. So red, blue, and it is green. So green LED should be in on condition, maintaining this is a high temperature. Else, so in between 80 to 75, so 75 to 87. So if it is within that voltage, so then the middle LED should be in on condition, and we have to maintain it as a print as a moderate temperature, and this should be in continuous loop. Okay, so this is a code, and I'm starting simulation. First time it is in on condition, right? So if I want to change the whether it is blue means it is in cold condition. So suppose if I want to increase, how to vary the temperature value? So if I click on the LM35, there is a bar on top of this that I can change. If it is very less value, it is in green condition, and if it is in very high value, it is in red condition. And in between, wherever it is between the 85 to 87 to 75, the it will be yellow LED will be in on condition. Yellow in terms of this lightest color, so this is your yellow color. Okay, so this is in on condition. So these are the three type of uh, LEDs in a one manufacturer item, that is tricolor LEDs. So the left, this is the purpose of this temperature sensor. Wherever we go, that is if the temperature is very high. So suppose if the this application can also be extended, like I can keep one buzzer here. If the temperature is too hot, so the buzzer is in on position, it will click on, continuously in on condition. So once it is settled down to a normal temperature or less than temperature, then the buzzer is in off state. So that is the another one. Or the another application of this is I can connect a LCD 16 by 2. So means that 2 rows and 16 characters on that particular LCD. So I can connect that LCD over here, so to display whatever the value of the temperature. And I'll show you where is this serial monitor. So if you see this, the last one is a serial monitor. If I click on this, it will be showing temperature colon 96.69. So this is the temperature. So suppose if I change this value, the value also changing over here. So that is 44.83, and the color of this is green. Okay, and if it is like a 103, that is above, it is maintaining it as a hot condition, so red light is in on condition. Okay, red, green, and finally it is in a blue color. So when will you get to the blue color? The between range. Okay, if it is much less, green color, much hot, it is in red color. Whenever it is in between, so that is blue color. Is it visible? Is it visible? Blue is in on condition. Okay, so that depends upon the temperature, what is the value you are changing. Okay, if you are changing to lowest value, that is minus 29 degrees, and it is representing it as low temperature. So if I want to maintain the medium temperature, it should be between 75 to 87. So what is the value it is reading? 86. Okay, so suppose if I'm going to the towards right side, so that is your hottest temperature. Okay, so this is one of the application of temperature sensor. And similarly, so this I can change it to temperature sensor project. Okay, and similarly, I have given you the another one, that is ultrasonic sensor. So we will do one example here. Before that, what is ultrasonic sensor? As I told you already, ultrasonic sensor is used to measure the distance, how close the object to your system is. Okay, and what is the range between your transmitter and the receiver. So, and this is the basic principle of this works based upon the echo concept, how much it is transmitted in terms of a sound signal and how much it is reflected back to the transmitter. So that is reflection back to the transmitter is called as a echo signal. Okay, so how much it is transmitted, that is, we'll call it as a trigger signal. How much it is come back to the transmitter, we'll call it as a echo signal. And there are two types of ultrasonic sensors. So one is, we'll call it as a ping, the other one HCSR04. So the HCSR04, it consists of 4 leads, whereas the ping we are having only 3 leads. So in these 4 leads, the trigger and echo signals are separate pins. The other 2 are VCC and ground. But here, if I combine the trigger and echo on the same pin, that is a 3-pin ping ultrasonic sensor. Okay, so these are the two differences between the ultrasonic sensors. One is having 4 leads, separate trigger, separate echo signal lead, and for ping we are having only 3 leads. Both the trigger and echo is only the one middle one. The other 2 are VCC and ground. Okay, so these are the ultrasonic sensors. So how it is going to work here is based on this particular figure. So initially I am maintaining the ultrasonic sensor at a low level. Initially it is in off state. So once the trigger is given, so trigger is nothing but once the stimulus is given to that, so that stimulus, it will raises that and keep on maintaining that stimulus over a period. So that period I'm calling it as a duty cycle. Okay, so over a period of amount of time, so this trigger is in on condition. Okay, so once the trigger reaches the receiver, it gives it wait for a echo signal. So the transmitter is waiting for the echo signal from the receiver side. So once the receiver is sending some echo signal in terms of echo back to the transmitter, so then this particular ultrasonic sensor uses to try to measure the distance here. Okay, so this is the flowchart of that particular ultrasonic sensor, and this is one example where I'm connecting this Arduino to a particular HCSR04 ultrasonic sensor and a breadboard, and there is a potentiometer and there is an LCD. Okay, so if I do all these connections as per this circuit, and there is a code I have to mention in that text block. So this is a code. What this code says us. So there is a trigger pin. I'm connecting it to a pin number 9 of the digital pin, and echo pin I'm connecting it to a digital pin of 10th pin, and I'm maintaining some liquid crystal display LCD and connecting only so this is having out of 8 pins, I'm connecting only this 6 pins, 1, 2, 4 and 5, 6. I'll increase the font for this. Let's check. So I'm using the liquid crystal display LCD, only these number of pins out of 8 pins, and trigger pin I'm connecting it to a 9th pin, and echo pin connecting it to a 10th pin. Okay, so and I'm measuring the distance in terms of a centimeter and in terms of a inches. Okay, so now, so coming to the setup function. So first I have to start the LCD dot begin. So which is having 16 characters, 2 rows. So 16 by 2. So 16 characters are there in each of the row. Okay. So or sometimes we can say this as 16 by 2. So that is 16 columns, 2 rows. So any other sense is correct. Okay. So this pin mode, trigger pin is a output mode, and whereas the echo pin is acts like an input pin. So next, coming to this loop function, first what we have to do, first I have to give a trigger to the trigger pin. So first I have to give a start the transmission by stimulating this trigger pin. So initially it is in low, so then I have to make it as high, and I have to maintain for a over a period of pulse. So that pulse period I'm calling it as 10 microseconds. Over a period of time it is in on condition. So once it is low, it tries to wait for a echo from a receiver. So that acts as an input pin. So the pulse in is echo pin is automatically it made it to high. Okay, so you know the distance in centimeter is nothing but, so what is this 0.034? Anyone has guess here? 0.034 is nothing but this is a sonic distance. So how much is the with respect to sonar distance, how much it is there in terms of a centimeter? And why we are doing by 2 here is echo is nothing but it is a two-way communication. First from transmitter to receiver, again the same distance it has to travel back to this. So any one is sufficient to calculate the distance, right? So we are doing by 2. And in case of the inches, so the sonic distance in inches is 0.0133. That is a standard value. And for because it is a two-sided, I am making it as a half side, that is by 2. Okay. So now, so LCD, I have to start with the first row, first column. So that is 0, 0. So what I have to write here? I have to write like what is the distance, and distance in centimeter, and whatever that centimeter value on the first row. And in the second row, so this second bit refers the row here. Okay, so the second row I have to mention what is the how many number of inches I'm having. So if you observe this, if you observe, this is the first row, it is maintaining distance is 48 centimeters, and the in inches it is 19 inches. So this is a LCD display, and if I click on that particular HC SR04, yeah, there is an obstacle, and if I keep on moving that, it is maintaining how much it is how far it is from the particular sensor, that it is maintaining in terms of a inches and centimeters, the same values here. How many inches? 19. Here also it is showing 19 and 49 centimeters. So the same conversion with respect to centimeters. Either of this you can use. Okay, so this is a design. Okay, I'll show you how it is going to work out. I'll show you already the existing one. Here. If I want to open again, it will ask you like tinker this. So if I click on this, the existing one is there. But this is the experiment I did with respect to ping one. So ping is having only 3 terminals. So the echo and the trigger, which is of combined pin, that is the middle one. Okay. So and here I am trying to control this LED on and off by measuring the distance between this and the particular object. So if I see the text here, or if I see the block coding here, I want to explain the block code here. So set, first I'm declaring one local variable, creating local variable, call it as dist here. So and then go to the output, set that particular distance. So I am keeping this value here, set the particular distance, and read the ultrasonic distance. And if this particular distance is less than or equal to 100 centimeters, so keep this 12th pin is in on condition. What is the 12th pin? That is a LED. So if the particular distance between the object and the sensor is less than the 100, I am turning on this LED in on condition, else the LED is in off condition. So suppose if I start simulating, you will come to know. So I have to click on this particular one. There is an object here. Okay. If this particular distance between the sensor and the object is greater than, less than or equal to 100, LED is in on condition. So it is in off condition till now. Okay. So it is in off condition. So suppose if I keep this value as less than 100 centimeters. Now you observe carefully. What is the distance between, this is an object, okay, this is a sensor. So the distance between these two is 53.4 centimeters. According to our code, if it is less than 100, I can keep my LED is in on condition. So suppose if I make it as above 100, see here 104.0 centimeters, LED is in off condition. So the same thing I can replace this by HCSR04 ultrasonic sensor also. The same thing. Okay. So this is by means of using the block code. So anything you can write either block code or the text. If you are comfortable with the code, text code, then you can write directly. Otherwise, you can construct this block code. Okay. So this is a ultrasonic sensor. Any doubts here? So what we have seen here is, what is the temperature sensor, what is the theory behind it, how we can calculate in terms of a Celsius or Fahrenheit, what are the formulas for that, and how to convert, how to interface this ultrasonic sensor. Two type of sensors. So one is ping sensor, the other one is HCSR04. So HCSR04, I have written the text code, and for ping I have showed you this block coding. Okay. And there are some other sensors like a PIR sensor, or this is a control of LED by means of potentiometer. You know the potentiometer, right? So potentiometer is used to, if I rotate, there is a knob here. If I try to rotate this particular knob of the potentiometer, so the corresponding loop, the circuit voltage is also going on changes. Okay. So it is mainly, this is a principle behind in this. If I do the simple connections like this, and it will show you how the LED is controlling by rotating the knob of this potentiometer. Okay. So, and then the next one is by using the LDR. You know, the LDR is a light dependent resistor. So this resistance, whatever this, the intensity of the light, if it varies, resistance is also varies. So if I do the simple connections like this, and if I write the corresponding code to control the intensity of this LED, so then it interfaces with the LED. Okay, lights LDR. Okay, and these are the exercise questions I want you to practice. So whatever the temperature sensor I've shown, and this can be connected to a, instead of cold or hot variation, I can keep one buzzer. If the temperature is less than 100, no means of buzzer. If the temperature is greater than buzzer, 100 degrees, the buzzer has to ring up. Okay. So similarly, ultrasonic distance sensor also, we can keep the buzzer in place of LED. Okay, so earlier we kept, I've shown you the LED, how it is controlling. If the distance is less, LED is in on. If the distance is more, LED is in off, right? So in place of LED, we can keep one buzzer. So if the distance is more, buzzer is going to ring up. So if the distance is less, buzzer is in off condition. So similarly, so the push button can, we can use how it is going to control the intensity of the LED. And similarly, PIR sensor. I told you what is PIR? Passive infrared sensor. It is used to detect the warm body surrounded by that particular sensor. So if any living organism like a human or animal is surrounded by that particular sensor, it is used to detect. Okay. So, and I can connect a buzzer to that sensor, so that if the person is near to that sensor, it usually will use this PIR sensor to attach on the doors whenever we are going out of the station. Okay. So suppose somebody, any robbery want to enter the house, the PIR sensor, if the person is nearby, so the PIR sensor, with the help of buzzer, it rang up, so that whatever the watchmen are, they can alert. Okay. So this is the use of this PIR sensor. Thank you.